Hey, math class. Okay, today we're going to look at multiplying fractions. And I actually think that multiplying fractions is way easier than adding and subtracting them. So you'll probably like this a lot better, excuse me, than adding and subtracting. Even though we've kind of got those taken care of, multiplying is really easy in comparison. And so unlike with adding and subtracting, where I recommended that you write everything vertically, with multiplying I recommend that you write it horizontally like this. And so you'll kind of see why that becomes important. At this stage though, it's easy, it makes it easy for me to see that I multiply my top numbers together and my bottom numbers together. And that's it. That's all that I do. And if they're vertical, I know I lied. If they're horizontal, if they're written this way, then I can easily see that I need to multiply these two numbers together and those two numbers together. So let's do that. 2 times 4 is 8. 3 times 5, 15. Okay, so now I have this answer. I have to think to myself about my two questions, right? Question number 1, is it a proper fraction? And in this case, yes, it is. Smaller number is on top, so it's a proper fraction. Is it reduced down as far as it can go? So again, in order to do that, I got to find my greatest common factor, right? So here are the factors of 8. Here are the factors of 15. I think that's all for 15, but none of them are the same, right? The only one they share in common is 1, so I know that this is reduced down as far as it can go. Let's look at another example, because you're probably thinking to yourself, oh my gosh, it can't just be that easy, and it really kind of is. It really kind of is that easy. Here I have 4/5 times 5/8. There, that makes it a little better. You can kind of see that better now. So again, I'm just going to multiply straight across. 4 times 5 is 20. 5 times 8 is 40. Ta-da! This one, is it a proper fraction? Because I got to ask myself my two questions. Yes, smaller number on top. Is it reduced down as far as it can go? 20 over 40. No, it's not. And in fact, for this one, I can use the 0 rule, where I just cross out the zeros. It's like I'm dividing by 10, and all that I'm left with then is 2/4. Is that reduced down as far as it can go? Nope. They're both even, so I can divide out 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I can see that 4/5 times 5/8 equals 1/2. So if you didn't want to do all of this reducing work in a problem, there is a way around it, because like these are kind of all nice neat numbers, you know, 20 over 40. Those are kind of big, but I can still sort of deal with them. If you don't want to deal with all of this reducing stuff, then you can do what's called cross-canceling. And let me get a couple of examples here for that. And we'll talk about what that means. So cross-canceling, I want to look at, again, you need your numbers in the horizontal direction here. I want to look at the numbers that are diagonal from each other. Okay? I think I wrote this problem down wrong. Because I could say, gosh, I can just multiply across, and 9 times 8 is 72, and my bottom number is whatever 16 times 15 is. That's a super huge number. I don't really want to have to deal with anything that big. Or I can cross-cancel within the problem, okay? So let me show you how we do that. We, again, look at the ones diagonal from each other, and I'm literally going to pick numbers out of the sky. I'm looking for the factor that they have in common, but it doesn't have to be anywhere in this problem. So this first one, if I look at 8 and 16, they have a lot of factors in common. They have 2, they have 4, but they also have 8. And so I'm going to say to myself, okay, what's 8 divided by 8? That is 1. What's 16 divided by 8? That is 2. Okay, so that one's really easy because the number was like right there. It gave me a hint. But these ones I have to sort of think about. Okay, what are my factors of 9? Well, 1, 3, and 9, right? Those are my factors of 9. My factors of 15, that's funny that that's come up twice now, right? Aha! Look, my greatest common factor is 3. So I'm pretty much pulling this 3 out of the air. It's nowhere in my problem, but I'm dividing both 9 and 15 by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And so I write down the number that I have left. You hopefully saw me do that. And now I'm going to multiply those new numbers that I've created to find my new top and bottom number. So 3 times 1, 3. 2 times 5, 10. There's my new fraction, my answer. Without having to, get 72 over a big humongous number and reduce it down that way, I've reduced within the problem. And it's just really nice and handy to do it this way. Okay, so now I've got an answer. I got to ask myself my 2 questions. Is it a proper fraction? And in this case, yes, it is. 3 smaller than 10. Is it reduced down as far as it can? And if you notice, 3 is prime, right? So the only way I could reduce that down is if it divided evenly into 10. So I know that 3/10 is my answer. Let's look at one more example here. Oop. This was a 2 right there. 5/22 times 11 over 14. Well, okay, in this problem, it looks like I'm only going to be able to find a common factor in one direction, right? Because 11 and 22 can both be divided evenly by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. But there's no common factor besides 1 for 5 and 14. So I just have to leave those guys there. Okay, so 5 times 1 is 5. So I'm going to multiply the number that's there times the new one that I created. 2 times 14. Oh gosh. I think I know it, but let's just make sure. 28. My new denominator is going to be 28. So then I ask myself my 2 questions. Is it proper? Yes, it is. Smaller number on top. Is it reduced down as far as it can go? And again, 5 is prime, right? So the only way I could reduce that down is if I've divided evenly into 28, which it doesn't. So I know that I'm at my lowest fraction version. Let's look at some examples because I'm going to try to throw a wrench in it here and try to make it a little bit more challenging. What happens if I have a whole number? See this 4 right here? He's just a whole number. He's not a fraction. And in subtracting, we had to do a whole bunch in order to make a whole number into a fraction, right? But in multiplication, all we have to do, draw a line, put a 1 under it. And then we can cross-cancel, do whatever we need to do to solve this problem. But that's it. That's all we do. Super easy. Isn't that awesome? So now this one, there's nothing that I can cross-cancel, so I'm just going to multiply straight across. This becomes my top number. This is my new bottom number. So 4 times 3 is 12. 1 times 7 is 7. Okay, so now I have to ask myself my 2 questions, right? Is this a proper fraction? Oh boy. No, it's not, right? I've got a bigger number on top than I do on the bottom. So we got to go back to thinking about how we solve that. And if you remember, we're going to divide the bottom number into the top number. So 7 can go into 12 one time. I'm going to multiply 7 times 1, which is 7, and write it underneath, and then subtract. So I have 5 left over. So my answer is going to be 1 and 5/7. Okay, so I answered question 1. Question 2, is this reduced down as far as it can go? And in this case, yes, it is, because actually 5 and 7 are both prime. So I've got 2 prime numbers. I'm reduced down as far as I can go. So 4, the whole number 4 times 3/7 equals 1 and 5/7. Let's look at another example of that. Okay, here we go. 11 over 40 times 20. This is a whole number, right? All I have to do, draw a line, put a 1 under it. and then I can solve. I can cross cancel in everything, whatever I need to do. Well, 20 and 40, I can divide 10 out of both of those, right? 20 divided by 10 is 2. 40 divided by 10 is 4. But oh my gosh, I still have two even numbers. I'm going to divide out 2 out of both of them now. 2 divided by 2 is 1. 4 divided by 2 is 2. So there, I didn't get to my greatest common factor right away, but that's all right. I can still cross cancel as many times as I need to reduce it down in the problem as far as I can go. Okay, so now I'm going to take this 11, because I can't cross cancel anything this way, right? 11 times 1 is 11. 2 times 1 is 2. And so here is my new answer, right? 11 over 2. Question 1, is that proper? And again, no, it's not. So I have to come over here, divide my bottom number into my top number. 2 can go into 11 5 times. 2 times 5 is 10. I'm going to subtract and find my remainder. So what this tells me is 5 1/2. I'm going to scooch that 2 over just a little bit. Right? My whole number becomes, or the number on top of the bracket becomes my whole number. My remainder becomes the top of my new fraction. The bottom number stays the same. And that's reduced down as far as it can go, right? Because I've got 1 over 2. 1 over something means it's reduced down. So I know that 11/40 times 20, the whole number 20, equals 5 1/2. We're going to look at some more examples of multiplying fractions in the next video.